Hello guys, I'm Divya. Now I'm going to discuss about my digital assignment 1 for my computer organization architecture course. And for this I have to choose my microcontroller and microprocessor, and I have chosen CY8C61X7, and this microcontroller was manufactured by Cypress, and the datasheet which was taken for reference is dated on June 2020. And for drawing this block diagrams and all, I've taken and I've used a pages.com, as I have this default option for Mac OS. Now coming to the first question, we are asked to draw the microcontroller block diagram and the internal parts, and this is the basic block diagram of the microcontroller taken. And as per the internal parts, here we have a CPU, analog digital blocks and interfaces, and these are the block diagrams for the internal parts. And the CPU has DMA microcontroller as its internal part, and the block diagram of DMA microcontroller is this one. So, and as per the communication interface, this is a block diagram of the communication interface. Now coming to the second question, we are asked to provide the instruction set of the microprocessor or microcontroller, and as far as this microcontroller, there are two ARM Cortex CPUs, Cortex M4, which has a FPU, which is floating point unit, that supports single cycle DSP instructions, and Cortex M0 Plus, which has MPU, which is my memory processing unit. Cortex M4 implements a version of thumb instruction set, and Cortex M0 Plus supports ARM v6m thumb instruction set. And this is the table that describes which CPU is used for which function. And this table, these are the instructions used in the functioning of the CPU, like addition, multiplication, etc., move instructions. Now coming to the architecture of the microprocessing element or the microcontroller. As I said before, PSoC 6 microcontroller contains dual CPU architecture with both CPUs on its single chip. It has Cortex M4 and has which is used for higher performance tasks, and Cortex M0 Plus for low power tasks. ARM Cortex M4 processors are based on hardware architecture, but Cortex M0 is based on human architecture. And now coming to the comparison of our architectures with the architectures mentioned in our chapters. Here we have used in our chapters we have one human architecture and hardware architecture in the module 1. These are related to module 1. And most of the computer systems, the CPU receives instructions and data from input or memory. The instructions and data are processed by CPU, and the results are either sent to an output or transferred to the second storage. Architecture is the design that enables the instructions and data to reach and be processed by the CPU. And in one human architecture, programs, data and instructions are stored in the same memory, and we are using Cortex M4, we are using Cortex M0 Plus for these for lower performance tasks, and this is going to be implemented using the one human architecture. In hardware architecture, there are separate storage and separate buses for instructions and data, and this is derived from one human architecture. In Cortex M4 implements the hardware architecture, as it is used for higher performance tasks. And coming to the fifth question, which is the organization of registers in the microcontroller. Both CPUs have 16 and 32-bit registers, and in those 32-bit registers R0 to R12 are used as general purpose registers. R13 stack pointer, R14 is used as a link register, R15 is used as a program counter, and for FPU which is used by which is implemented by Cortex M4 CPU, there are 32-bit single precision registers which are from S0 to S31, and these registers can also be addressed as 64-bit double precision registers which are from D0 to D15. And for this registers we have control and status registers, which states the status of the register. These are CPACR, FPCCR, FPCR, FPSCR, FPDSCR, and here there are 32 FPU registers listed. And coming to the algorithm of the mathematical calculations we are used, here this is described. Now we are going to talk about the memory management system in the microcontroller. We have chosen PSoC 6 contains flash, SRAM, ROM, eFuse, memory block as its memory blocks. In flash there is 1 MB of application flash, 232 KB flash sectors, and one of them is auxiliary flash and the other is supervisory flash, which is S flash, and also it has 2 cache memories. Up to 256 KB of SRAM is provided. 128 KB of RAM, also called supervisory ROM, SROM, provides code for several system functions. Cortex M4 and Cortex M0 Plus have ARM memory processing units, also known as MPUs, for protection at bus master level. Shared memory protection units help in memory protection for memory resources that are shared among the multiple bus registers. Now I'm going to show you I'm going to show the data sheet of the microcontroller chosen, and this is the data sheet, and this is the basic introduction. Here the block diagram and internal parts are given. Firstly I've taken just block diagram, like from this part the system resources and from this part CPU subsystem, and for the internal diagrams I have taken the whole part, and this is the functional description of each and every part discussed in the block diagrams. Now coming to the block diagrams, I have chosen pages.com for this. Now here is the block diagram I have drawn before in the Word. Now I'm going to include some parts here. Digital blocks, and for this block I have to take shapes here. And for the color change, here it is printing in white, so let me change the color of the text. It's black. The part of the digital blocks are EWN stress. Now the detailed block diagram is also ready, and this is how I've done my DA1. So thank you. If you like my video, please like and share my video. Thank you.